Hello, Yishmarai. I like making stuff and building things. This is what my desk very often looks like. Right now I'm building a camera stabilizer. So today I'm going to talk about plutonium, and that requires a little bit of background information. You know, in case you just flew in from Mars or somehow forgot everything you learned in school, or if you maybe haven't learned it yet. So everything around us is made up of atoms, and atoms consist of neutrons, protons, and electrons, which in turn are made up of smaller pieces, but those are not important right now. What decides what kind of substance something is the amount of protons contained in the atom's nucleus. Take something like helium, for example. Helium normally on Earth has 2 neutrons and 2 protons. If you have a helium atom that contains 2 protons but 3 neutrons, then that's called an isotope. If the number of protons changes, then it stops being helium and it becomes something else. And most chemical elements generally have like one stable isotope that is the most common one appearing in nature. Now, if the chemical element is not stable, then it's usually called a radioactive isotope. And plutonium is one of those. What is radioactivity? Radioactivity is when an unstable atom transforms itself into a different kind of element by spitting out parts of its nucleus, or by spitting out gamma rays, electrons or positrons, which don't change it into a different element. Plutonium can only be created in 3 different ways. Inside really massive explosions like the Big Bang or inside a supernova, inside nuclear power reactors, where the uranium fuel eventually turns into plutonium, or 3 spontaneously in nature, where concentrated uranium ores make the same thing happen as inside a nuclear power reactor, only on a way smaller scale and slower. Because there are tiny amounts of plutonium floating around in space and on Earth, humans have always had a tiny amount of plutonium in their bodies. Plutonium is mainly used for making nuclear weapons, and there are decent amounts of it inside nuclear power reactors as well. To date, 2,053 nuclear weapons tests have been conducted, over 570 of those in the atmosphere, where they released the radioactive material all over the place. That, along with some plutonium being released in nuclear power accidents, has resulted in humans nowadays having an amount of plutonium in their bodies 5 orders of magnitude larger than in the 1940s. Oh, and the atomic bomb dropped over Nagasaki in 1945 also didn't help. It's still an incredibly small amount, and it's too small to do any damage, probably, but it's still kind of a creepy idea. Another creepy detail is that during the 40s, in what is known as Project Manhattan, where the United States developed nuclear weapons, they also did some other kind of sketchy things, like inject people with plutonium. Between 1945 and 1947, 18 people were injected with various amounts of plutonium without informed consent. Basically because the doctors wanted to know what it does to you and how they could come up with like guidelines and rules for how to work with plutonium safely. The United States Atomic Energy Commission continued with various experiments up until the 70s. The US government covered these things up until 1993, when Bill Clinton had a committee research them. The committee issued a report that said wrongs were committed. Plutonium is kind of a nasty element. Even disregarding the ionizing radiation, it's chemically toxic, and ingesting even a small amount of it can kill you. It's been called the most toxic substance on Earth, but that's not entirely true. It is toxic, but compared to other things gram by gram, arsenic cyanide and caffeine are more toxic. That's why you shouldn't drink like 10 bottles of energy drinks per day. That's stupid. When talking about radioactive elements, you're often going to hear the word half-life. It's kind of an important factor when talking about radioactivity. Half-life is the amount of time it takes for any specific element to lose half of its radioactivity. For any radioactive element, the half-life depends on which isotope you're talking about. For plutonium-239, the half-life is about 24,100 years. Note that half-life does not mean that the stuff stops being dangerous, because it doesn't necessarily decay into something that is not just as radioactive or even more radioactive. Pure plutonium is a silvery white metal like this. This is not plutonium, this is pewter. But if it was plutonium, this is what it would look like. Also, I wouldn't be insane enough to hold it with my bare hands. But in spite of all its dangers, plutonium is a very useful element. The most common isotope on Earth is plutonium-239, because that's the one that is the most useful for making weapons. But we also use plutonium in fuel for nuclear power plants, as an energy source in satellites, as a neutron emitter for research, and it's also being used as a power source in pacemakers for heart patients, though most of those have nowadays been replaced by lithium batteries. I finished the camera stabilizer. I think it turned out pretty good.